You know, every single time you send an email, stream a show, or even just browse a website, you're tapping into a set of rules that were written decades ago. And if you really truly want to understand how our digital world actually works, well, there's one essential guidebook. Today, we're cracking open what is basically the owner's manual for the entire internet. So this is it, TCP/IP Illustrated Volume 1. For decades, this book has been the go-to guide for anyone who builds, manages, or tries to secure the internet. And let me tell you, it's so much more than a textbook. It's practically the blueprint of our connected world. And hey, don't just take my word for it. Right from its very first edition, people were calling it the Bible of the field. And that's a status it's somehow managed to maintain for decades. So what's the secret? What gives this book such a legendary reputation? Well, let's dive in and find out. All right, so here's our game plan. First, we'll dig into why this book became known as the Bible of networking. Then we'll look at its really unique show don't just tell philosophy. After that, we'll take a quick tour of the internet's architecture as the book lays it all out. We'll also see how it was totally remastered for the modern internet. And finally, we'll talk about its incredible, enduring legacy. So seriously, how does a technical book get a nickname like the Bible? It's because it did something absolutely revolutionary at the time. It made the invisible visible. It took all these abstract rules about internet traffic and literally showed a generation of builders exactly how data packets move from point A to point B. The real magic, though, the thing that sets this book apart, lies in its core philosophy. And it's hinted out right there in the title, Illustrated. Now, this wasn't just about throwing in a few extra diagrams. No, this was a completely new way of teaching that honestly changed everything. See, most networking books back then were just all theory. Abstract diagrams, walls and walls of text. But TCP/IP Illustrated took a totally different path. It was all about seeing the protocols in action, like literally watching the three-way handshake of a TCP connection form, packet by packet. It showed you actual data traveling on the wire using real-world examples. It's the difference between reading a map and actually taking the journey yourself. This quote right here just nails it. The author, W. Richard Stevens, he didn't just tell you how TCP/IP worked. He put you inside it. He used diagnostic tools to capture live network traffic, making all that invisible stuff suddenly visible. You weren't just learning a bunch of rules. You were actually watching the game being played out bite by bite. Okay, so what does this journey through the internet actually look like? Well, the book takes this really elegant, layered approach. It deconstructs the entire protocol suite from the ground up, showing you how each and every piece builds on the last. The book just breaks it all down, layer by beautiful layer. You start at the very bottom with the physical networks like Ethernet and Wi-Fi. Then you move up to the Internet Protocol, or IP. That's for the global addressing. Above that, you've got DNS, which handles translating names to addresses. And finally, you get to the real workhorses, UDP for speed, and of course, TCP for reliability. Think of it like this. It's like you're addressing your data for a long journey. Your email starts out as just plain data. First, as you see here, it gets a TCP header. That tells the network how to handle it, reliably. Next, the IP header gets slapped on, which tells it where in the world it's going. And finally, a link layer header is added, which just tells it the very next hop on its path. The book just visually walks you through this whole process one layer at a time. It's brilliant. But here's the thing. The internet of 1994, it is not the internet of today. Not even close. So this original masterpiece, it needed a serious update. And this is the crucial part of the story, how this foundational text was remastered to stay relevant. I mean, just look at how much changed in just a couple of decades. After the first edition came out in '94, the web just exploded. Wi-Fi became a thing everywhere. All these new security threats popped up, and technologies like NAT completely changed the network landscape. And then, this is the critical point. In 2011, we ran out of IPv4 addresses. The internet's very foundation was cracking, and the book had to be rebuilt for this brand new reality. And the second edition, which was revised by Kevin Fall, did exactly that. It wasn't just a little touch-up, it was a massive overhaul. It integrated IPv6 throughout the entire book. That's the successor to the original Internet Protocol. It added huge sections on modern security like IPsec and TLS, detailed how wireless networking works, and it confronted the new realities of NATs, firewalls, and even direct attacks on the protocols. Basically, it documented the internet that we all actually use today. So this brings us to the book's legacy.
You have to wonder, in a field that changes at lightning speed, why does a book first written decades ago remain so absolutely essential? Well, when Vince Cerf, and we're talking about one of the literal fathers of the internet here, calls your book invaluable for the engineers who are securing and refining how the network operates, you know you've created something timeless. I mean, that's pretty much the highest praise you can possibly get in this field.
So, why does it endure? It really comes down to three things. First, it teaches core principles, not just specific code that gets outdated in a year. Second, its illustrated method, that philosophy of learning by seeing, is just a timeless way to teach. And finally, it evolved. It didn't get stuck in 1994, it updated itself to become the definitive guide for the internet we have right now.
And that leaves us with one final thought. The internet is nowhere near done evolving. As we move into this crazy new age of AI-driven networks, quantum communication, and the Internet of Things, the challenges are going to change all over again. So the real question for all of us is, what are the next fundamental concepts we're going to need a book like this to make visible for us? What's the next thing we'll need to illustrate?